MVC and Web Forms take very different approaches to handling HTTP requests. In this lesson, we want to explore the overall request lifecycle of the MVC framework and the role that controllers play in this process. The MVC request lifecycle is initialized through a combination of routing and an HTTP handler, which we discussed a bit earlier. The routing engine matches the incoming URL to one of the routes registered with the application. In an MVC application, each route is associated with the MVC HTTP handler, and that acts as sort of a gateway into the framework. We'll discuss this more in the next lesson. This HTTP handler builds a controller to handle the request based on the route information populated from the URL. These controllers are classes composed of action methods. The framework decides which method is the best match to generate a response for the current request and executes that action. These are the methods that use your business logic to build a data model that should be sent back to the user. They also decide what format it should be displayed in by returning action results. These results could format the data as anything from JSON to XML, but often they're HTML views. Views are parsed by a component called the view engine, which generates the proper markup based on your server-side helpers. We'll be working with each of these sections on some level as we build our app, but for right now we really want to focus on controllers. In an earlier lesson, we used this diagram to explore the application lifecycle and to see where the Web Forms page lifecycle fits into this larger process. Well, since the MVC framework is accessed through an HTTP handler, just like Web Forms, its entire request lifecycle also runs within these handler execution events. The only exception to that is routing, which occurs at an earlier stage and selects the MVC handler for later execution. At the most basic level, MVC controllers are simply classes that implement the iController interface. Usually this is accomplished by simply inheriting from the base controller class that's provided by the framework, which implements iController behind the scenes. This base controller handles an extensive amount of work for you, which is why you generally won't implement the raw interface yourself. So as we mentioned, MVC handles HTTP requests by mapping them to methods on controllers. These methods are called action methods because they represent an action by the user. A single controller can handle many requests and respond to each one with different types of data. Usually a controller is created for each logical feature or section of your application, though you can really organize them however you want. Action methods are selected by the MVC framework itself to execute for a request. You should never have to directly call them from your code. There's an internal component in MVC called the action invoker that uses a variety of criteria to decide which action method can best handle a request. MVC allows you to influence this decision through features like action selectors, which are applied to methods as attributes. This enables features like choosing one method over another based on whether the HTTP request is a GET or a POST, and other custom criteria as well. We'll discuss this mapping process more in the next lesson when we talk about routing. Action methods usually return an action result, which is simply a base class that offers an extension point for more specific types. The MVC framework ships with several action result types right out of the box, such as view results for HTML, and other types for JSON and just raw text responses and more. You should rarely have to directly write to the response stream in MVC. This should be handled for you by the framework and the action result that you provide to it. One question you might have is how the MVC framework converts a URL into data that can be used to build a controller and select an action method. In the next lesson, let's look more closely at routing and controller initialization to understand how requests are translated into objects and methods.